The topic is forces of attraction, and the forces of attraction that we will look at are the forces that exist within molecules or between molecules. We're going to look at these types of forces and class them based on either intermolecular or intramolecular. But before we do that, let's take a look at some of these forces. You would know at least three that you see on the screen, which is ionic bonding, covalent bonding, and metallic bonding. The three that we see on the right-hand side would be the new types of forces we will look at under this topic. All right, so I'll start with and I've heard it pronounced van der Waals, right, or van der Waals forces, as I say. These VDW forces are also referred to as induced dipole forces. They're called temporary dipole, instantaneous dipole, London or dispersion forces. I mention all the terminology in the event you're reading from different textbooks, but it all refers to the same thing, and our most popular terminology here would be to call it induced dipole forces. Next up, we have another type of force called permanent dipole-permanent dipole forces. And thirdly, we have one called the hydrogen bond. Now, in some textbooks, you may see permanent dipole forces just called permanent dipole-dipole forces, right? I refer to them this way just to cover the name of the force depending on what textbook you're looking at, right? So we'll move on to look at what is the difference between an intermolecular and an intramolecular force. All right, in this slide, I have distinguished the intramolecular from the intermolecular force. And I also want to go on to describe what's intra versus intermolecular. We say that intramolecular forces would be forces within a molecule and these molecules are able to stay together through some sort of force, and this type of force is what we call intermolecular forces. So these are forces between molecules. Later on, we're going to look at this in more detail, but I would like to mention it now. What is the difference between these intramolecular forces versus intermolecular forces? If we look at ionic bonding and covalent bonding, we will see they have a high bond strength. Compare this to hydrogen bonding, permanent dipole forces, and van der Waals forces. We see that these are weak forces of attraction. So intramolecular forces tend to be strong forces of attraction. That's ionic, covalent, and metallic. Whereas intermolecular forces of attraction, which are hydrogen bonding, PD forces, which is permanent dipole forces, and van der Waals tend to be weak forces of attraction. Later on, we will look at classifying our weak intermolecular forces of attraction from quote-unquote the strongest to the weakest. But in looking at the slide in front of you, you should be able to look at the bond strength and be able to tell me, in terms of our three intermolecular forces, which is the strongest and which is the weakest. Having discussed what's an intermolecular versus an intramolecular force of attraction, I must mention the relationship between these forces of attraction and the states of matter, which is our three states of matter: solid, liquid, and gas. As stated in the syllabus, they want you to be able to relate the force of attraction. And when I say force of attraction, I'm talking about the force of the intermolecular forces of attraction and the state of matter. So we'll just talk about it in a little detail and I'll summarize what they want you to know. So we're talking about the strength of the intermolecular forces of attraction, meaning that what happens as the strength of the intermolecular forces in one substance changes, right? So as the strength of the forces increase, which is the intermolecular forces, this means it should pull the molecules closer together. As the distance between the particles decrease, this means our melting point should change, meaning that the melting point is a reflection of the physical state of matter. As the distance between the particles decrease, this means we're going to go from a gas to a liquid to a solid. As we go from a gas to a liquid to a solid, this means that our gas should have weak forces of attraction, that is a low melting point, and our solid, which has a high melting point, should indicate that there are strong forces of attraction between the molecules. So what I'm trying to summarize here is that, so what we want to summarize as the relationship between the forces of attraction and the states of matter is that where we have strong intermolecular forces of attraction, this should indicate a high melting point, and the expected physical state of matter is a solid. As the strength of the forces of attraction decrease, melting point decreases, the physical state of matter changes from solid to liquid to gas.